Hello everyone! In this video, we want to present an implementation of a simple DC electric motor in a vacuum cleaner. Before we start the video, we have to introduce ourselves first. Starting with me, Oka Amanda from Biomedical Engineering, and the second one is Anastasia from Physics Engineering, and the third one Alia Shifa from Physics Engineering. And next we have Safira Salsabila from Biomedical Engineering, and the last one we have Zafar Siddiq from Biomedical Engineering. Okay guys, let's start with the Lorentz force.
A Lorentz force is a combination of electric and magnetic force in the electromagnetic field. This force occurs to the presence of moving electric charge or electric current in a magnetic field, while an electric motor is an electric machine that functions to convert electrical energy into mechanical energy, where the mechanical energy is in the form of rotation of the motor. Based on the voltage source, electric motors are divided into two, namely AC alternating current electric motor and DC direct current electric motor.
In these experiments, what happened is that the samples of the magnet and the samples of the electric were met, resulting in a repulsion reaction, which makes the electric wire rotate 360 degrees without stopping. This continuous rotation of the electric wire is called a simple electric motor, which is the application of the Lorentz force F close ELB sin theta. The information L is length of wire, E the current following in the wire, ampere, B stretch of magnetic field, Tesla, theta angle formed by N. The difference between the octaves and this variation lies in the number of turns, which can be calculated that the more turns formed on the coil, the slower the rotation speed 1 minute.
How the electric motor works. First, an electric current in a magnetic field will exert a force. Next, if the current carrying wire is bent into a loop, then both sides of the loop, i.e. at right angles to the magnetic field, will get a force from opposite directions. Third, the pair of force products torque to rotate the coil. And the last one, the motors have several loops on the armature to provide a more uniform rotational power, and the magnetic field is generated by an electromagnetic array called the field coil.
I will tell you how the vacuum cleaner tool works. First, the capacity of the air and dust mixture sucked by the vacuum cleaner can be determined using this formula. This formula is Q equals V dot A, where Q it means capacity, V it means airflow velocity, and A it means cross-sectional area of the hose. At higher air pressure to lower air pressure, the air pressure in the vacuum cleaner is reduced by the fan, resulting like a vacuum. The fan in the vacuum cleaner is driven by an electric motor, so the fan can rotate and accumulate pressure drops in the vacuum cleaner.
Axis A. Easy to assemble. B. The price is relatively cheap. C. Have great energy. D. Easy to control in the terms of speed and torque. Leg. A. Difficult to control at low speed. B. Taking care of it is quite difficult. C. Not suitable for high power application. D. In a dusty environment less than optimal. Conclusion. In this practical, it was found that the larger the coil, the faster the coil rotates, which is in accordance with the coupling moment formula where the magnitude is directly proportional to the rotating moment. Then it can be said that the area of the coil base affects the rotating moment of the coil, and the greater the number of turns, the slower the rotational speed.
This is our explanation of electric motor and Lorentz style. If you have any questions, please comment below. Thanks for watching. Don't forget to like and subscribe this video. Bye!